Hi and welcome to GeeksforGeeks. Today we would be discussing the problem construct list using XOR queries. So before I talk about this problem, let me give you a small disclaimer. There is a small bit of idea which is comparatively used a lot, not just in this question. And if you don't really know that idea, or if you don't have problem solving skill to that extent, you won't be able to crack the correct intended solution. That is why don't get disheartened if you are not able to solve this problem. There is a small idea acquainted with it. Fair enough. Let's move forward. We are given initially an empty 0 over here. Okay. And then after that, you need to perform Q queries. And the Q queries can be of two types. One is to add an element. One is to XOR all the elements. To XOR all the elements currently present. So let us first see the sample test case first. So if I just talk about the sample test case, and then after that doing everything, you need to return a sorted list of it. Now, the very first point we have 0. Then it is told that this value, that is add, if the first element is 0, we need to add that value. If the first element is 1, we need to XOR the value. Okay. And the corresponding next element, like in each query, you would be given a set of X and Y. This X tells you the type of query you need to do, either to add or to XOR. If it is 0, you need to add. If it is 1, you need to XOR. Then the next value is Y. Okay. So if add thing is there, then you need to add Y. If XOR thing is there, then you need to XOR all the presently given elements with the XOR of Y. So see, initially we have 0, then the very first element is 6, we need to add 6. Then we are told to add 3, added 3. Then we are told to add 2, added 2. Then we are told to XOR all the elements that is currently present with 4. So if we XOR all the elements with 4, then 0 XOR 4 is equals to 4. 0, 6 XOR 4 is equal to the value 2. And 3 XOR 4 is equal to the value 7. And 2 XOR 4 is equal to the value 6 itself. Then we are again told to XOR it with 5, which would make it 1, 7, 2 and 3. Basically XORing all the values with 5. This is XORing with 5. This is XORing with the value 4. Okay. After, so let me just give you, this would be the element after addition of 3 elements. Then if we XOR all the elements, the respective elements would be this. Then if we XOR it with 5, the respective element would be this. But then we get the value, after sorting it, we would get the value as 1, 2, 3 and 7. That is why the output looks like this. This is what basically you need to do. After getting all the values, you need to sort the values. So most of the time I tell, like if you have been following me, I tell to the lot of viewers, and whenever you are given a bit problem, visualize it in terms of bit. But here you don't really need to do that. Why? Because you just need to know something first, which is the cumulative property of XOR. So A XOR B XOR C is equal to A XOR B, then XOR with C. The very first property, there are two things that you need to do. The very first thing is that you need to know the property of XOR. And the property that is required in this question is the cumulative property of XOR. What is this cumulative property all about? A XOR B is equals to B XOR A. This basically means that the order in which we XOR does not matter to us. Okay. So it just means that, let's say we are told to do A, B, C and D, and we do something like D, B, C and then A, it won't affect it. Okay. So the ordering does not matter. Okay. If the ordering does not matter in XOR, we know that. Let's say up till this point you know this thing. Now the next thing we need to do is, I just want you to visualize over this. So let's say we have the elements as 0, 0, 0, 0, 0, 0. Okay, we have 6 elements. Okay, first you are told, let's say you up till now in the first iteration you have only one element, and you are told to add 1 to everything. Initially add 1 to everything, 2 to everything, 3 to everything, 4 to everything, then again 3, 2, 1, let's say. Now let us see the scenario. Now what I want you to do is, instead of XORing anything, just replace the problem statement to add. The problem statement would remain the same. You need to add elements. If you are told to do the operation add, you need to do it for all the elements that is present. Okay, so let's say initially we have only one element and you are told to add 1, then you would simply add 1. Then you have the second element. Let's, as of now for simplicity, just let us take 0 only, and then you are told to add 2 to the element. So what will you do? You would add 2 here also, you would add 2 here also. Then you are told to add one more element. This is the element. Then you are told to add one more element, and then you are told to add 3 to all the previous elements. So you added 3, 3, 3. You added 3 to all the previous elements. Then you add one more element. Then you add one more element to the list, and then you are told to add 2 to the list. So what will you do? You would add 2, 2, 2, 2. Previous all the elements that is present. Then you are told to add, let's say, 1 to the element. This time, let's say you are told to add 1 to the element. What will you do? You would add 1 here, 1 here, 1 here, 1 here, 1 here. Basically, instead of XORing, we are just adding the values. Instead of XORing, we would just add the values. So if we complete this queries, what would be the answer? The answer for the very first one would be 1. The answer for the second one would be 3. The answer for the third one would be 6. The answer for the fourth one would be 3 plus 2, 5, 5 plus 2, 7, 7 plus 1 is equals to 8. Then for this would be 2 plus 1, 3, 3 plus 2, 6, 6 plus 2, 8, 8 plus 1 is equals to 9. So this is the value that we have. Makes sense? So if you observe, this is the brute force approach. That whenever we receive that we need to add some value to all the elements that is present, we would start a for loop and add all the elements to the previous elements. Make sense? We would add all the values to the previous elements. Now instead of this fashion, if we go other way around, that is what, Siddharth? Let me explain you. Let's say there are 5 elements and you start reading the queries from the back. That is, instead of going from, the brute force approach was going from top to bottom. The brute force approach was going from top to bottom. This is the brute force approach. Okay. But the current approach would go from bottom to top. And let us see how this is optimizing it. So see, we have 1 here. So we add 1 here. So we add 1 here. Then we come across 2. So we know, let's see, this previous value would get added and this 2 would get inserted. So I would say previously what was there? 1. So sum is equals to 1. Currently we add one more 2 to it. So this would become 3 and I would keep it here as 3. Then we go to the third query from the back. Then we know that 1 and 2 would be included. See, 1 and 2 is getting included. Only third is getting added once more. So previous value plus 3 is making it 6. Now we go to the second element. So we know all the previous values plus the current value would be the value that is wanting this. So that would be 8. Then we know that all these values plus this value would make it this previous value plus 1. So if we go from the back, we have the prefix sum kind of thing or the running sum thing. Prefix sum we maintain an array, and in running sum we don't need an array, we just maintain a variable. So if you observe closely, if you go from the back, you don't need to traverse all the previous elements and populate them. Here, you know that, see, the idea is talking about the intuition, how this intuition is popping up, because intuition in my videos is the most important thing. So the intuition for this is that if you observe, this is getting carried to all the elements before it. This is getting carried to all the elements before it. This is getting carried to all the elements before it. This is also the same thing. So if we start from this point and we keep 1, that yes, I would add 1 to everyone. If we add up this 2 and we say that I would add 2 to all of them, the problem would be solved. So now, as XOR is commutative in nature, so instead of this something, we would store the cumulative XOR sum. And then as we progress further, we would just add the XOR. If element is needed, we would add it, because adding an element is constant. XORing all the current element is a problem here. So we would start reading from the back, and at the end, whatever elements we would simply return. So I hope I made sense. Let us go to the implementation and start off. As you know, I'm a very lazy person, so making all this as lowercase so that I don't need to hit the shift again and again. So now I would be first making an array list of integer. Array list of integer is equal to new array list of integers with no parameters. Now we would start, like initially we started with the sum as 0. Here also we can start with the sum as 0. Why? Because see, 0 XOR x is equals to x. Okay, that is why we can start off. So this would store the cumulative XOR value. Then we would start from the back. So the address of the last element of the query would be n-1, because array is 0 indexed. Array list is also the same. So now int I is equals to n-1, I is greater than equal to 0, and I minus minus. Okay, so I would get the very first type of query. So q dot get for the current index, I would get the type of query. If the type of query is just to add an element, so I would simply add that element. That is, I would say, just name it as a dot add. This is the element. So when we inserted the new element, we just, whatever sum we had, we would just added it. Current element that is needed and the previous sum we had. Here also, the previous XOR value we had and the current element. So we would simply XOR it with the current element. The same idea. Okay, we XORed it, and this would be the element. Okay, else what we would do is, else we have an element to XOR everything. Okay, so what we would do is, we would keep the XORed value. So we would say that simply keep the XORed value. Okay, if we are told to add anything, we would just keep it. Okay, at the end, when we have the last element, that is 0. Okay, so 0 would contain the cumulative XOR of everything. If you observe, initially we have the element as 0. See, this element, after processing all the queries, see how many values we were told to add. We were told to add only 3 values, but we got 4 values. How? Because there was one 0 which was concealed and which had the XOR of all the values. That is why towards the end we would add a dot add the value cumulative XOR of everything. Now we would simply sort the array itself, and then I would return the value of a. Now let us see if this solution is working or not. So the solution was absolutely fine, but the function definition changed. Earlier it was array list of integers. Now it is just a 2D array. So some modifications have been made. That is, now this is a 2D array. So instead of using that get, we just simply use I of 0 and I of 0, and here we use I of 1. This is a recent change that is done in the problem statement. So accordingly, new changes is this one. Let us test the solution if this is working fine or not. Seems like this idea is working fine. Now let us try to submit this and see if we can get an AC or not. And yes, we got an AC.